Alright, well, welcome back. We are going to discuss section 2 of chapter 2 and talk about velocity. So we're going to take all the stuff we talked about last time, position time graphs, motion diagrams, the particle diagrams, and now apply it to velocity. Okay, so to find out how fast an object is moving, we need two pieces of information. The change in time, remember that delta indicates change. Okay, and so this was t final minus t initial, and we need the change in displacement, or distance, which was d final minus d initial. When we do a position time graph, a steeper slope indicates a greater change in displacement during each time interval, which is speed. So the greater the slope, the greater the speed. So here I've got time, displacement. I could have something like this, or I could have something like this. So let's say this is object 1 and this is object 2. Well, if I look at the slope, those are beautifully straight lines. This slope is steeper, and so this would be considered a faster object or one with more velocity, or more speed if we're not indicating a direction. Okay, so slope is the average velocity, and I write v with a line because in the PowerPoint it wouldn't let me. So instead of writing all of this, you could just put that it's v with a line over the top, and that's the change in distance over the change in time. And so we've broken it into d final minus d initial over t final minus t initial. You could put this on your note card. I would just write it as average velocity is distance over time. Okay, so we talked about a little bit the difference between speed and velocity. Remember, speed is a scalar. It doesn't indicate direction. And so, for example, we have 5 meters per second, whereas velocity is a vector. It does indicate direction, and so we could have 5 meters per second west, or in a positive direction on a graph. So you can indicate, directionally like north, south, east, west, or just that it's positive or negative. That could also indicate direction. And a lot of times you get to choose the direction, so it's always good to choose things that are positive, and then the opposite of that would be negative, and we'll get into that as we go through some examples. Okay, so we talked about average velocity. We also have instantaneous velocity. So average velocity only indicates what happened at the beginning and the end of the time interval, because we're taking that like t final minus t initial. We don't really care what happened in the middle, if you went fast and slowed down or stopped or whatever. So that's average velocity. And the symbol for that is small v with a line above it indicating average. Instantaneous velocity is the speed and direction of an object at a particular point in time. So, throughout that trip for average velocity, picking out, at 10 seconds, what was the speed and direction at 20 seconds. Okay, that's instantaneous velocity, and that's just a small v, no line, because we're not taking an average. So, like if you wanted instantaneous velocity in your vehicle, you could use your speedometer, because that would give you specific points at that particular moment in time. Okay, so we talked about doing a position time graph. We know that for a straight line, the equation is y equals mx plus b. And on a position time graph, x is time. Our y is our displacement or our distance. Our slope is the speed. Because if we take slope is rise over run, right, which is y over x, change in y over change in x. Well, if we relate that to this velocity equation, it's change in distance over change in time. And so this becomes our v, or our m for slope, and then the y-intercept is basically the position at time 0. So here we would say that it's 0, but it could start here, and then this would give us a y-intercept. So for average, so we can take that equation, and then for average velocity, we can just plug in. So instead of y equals mx plus b, we have d equals velocity times time plus our distance initial, which is our y-intercept. All right, so here are a few examples to try. Again, we're going to go over these in class, and then we'll go over any questions you have. Okay, so before we get to the checks for understandings, here is another Chemistry Cat physics joke. So he says, do I like physics jokes? And only particular ones, like particles for quantum physics. Ha ha ha. Alright, take a minute, it'll sink in. Alright, let's go to the checks for understanding for velocities. Number 1, on a position time graph, what does the steepness of the slope indicate? Number 2, how is average velocity calculated on a position time graph? Number 3, what is the difference between speed and velocity? Number 4, what is the difference between average and instantaneous velocity, and give an example of each. And number 5, relate the equation for a straight line to the equation for average velocity. So we'll go over these in class, but give them your best shot. Have a good day.